So here we are. Sorry about that. I'm going to go through everything we went through in class today, just the first five for now. And then we'll talk about the next five after. I just want you to see what happens when we do all this stuff. And first problem was evaluate the absolute value. That's those bars right there. Let's see, the absolute value. I'll just draw right over it. The absolute value of a minus 8b if a is -3 and b is 1/4. And that's what it says. It says take your a, and we'll make that -3. So instead of a, we're going to take the absolute value of, let's use a different color here. We'll make it this green color here. We'll make it -3. And then we're going to subtract from that. And I think this is where we sort of fell off the rails, right? We had that 1/4 there and everybody started to get upset. I'm going to go 8 times that 1/4. And I'm going to put it like this. And I want you to sort of understand that when we have our 8, it's really 8/1. And then we can multiply straight across. So I'll close the parentheses, give me a second, or close the absolute value. Now I can evaluate this, and this comes down here. 8 times 1 is just 8. And then multiply the denominators. That's how we multiply with fractions, by the way. 1 times 4 is 4. And I apologize that 8 is not very pretty. And we're going to go backward and then just bring down that -3, right? Well, sorry about the colors. 8/4 is the same thing as 2, right? So I just put a 2 there. Well, now we're getting somewhere. -3 minus 2 is -5. Well, the absolute value of anything is just its distance from 0. So this is 5 spaces away from 0, or +5. So you'll notice that whenever you have a negative inside the absolute value, it just shows as positive because it's just showing that distance from the origin, or from 0. I use the word origin because we're going to talk a lot about that next year, but we don't need to worry too much about it this year. It's just our distance from 0. Let me get rid of this, and I'll move on to the next one. The next problem is solve this. Oh my gosh, solve this absolute value equation. And let's go ahead and change colors. Let's use this color. -4 times the absolute value of 3x minus 1, right, equals -20. And I expected most everybody to be able to do this. There were 2 ways to do this. You could distribute, or I'm going to do method 1 in this color, and then I'm going to do method 2 in a different color. An easier method in my humble estimation, but it might not be so easy for you. So I'm going to write it over here, rewrite it over here as a second way to do it. -4 times the absolute value of 3x minus 1, fix that subtraction, and that also equals -20. Now, when we talk about absolute value, we have to talk about solving for 2 different values. Whatever is in here could be positive or negative, and then multiply that. So I'm going to think ahead. What times -4 gives me -20? Well, it's going to be 5, right? 5 times -4 is -20. And so I'm looking for a 5. Well, the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So I'm looking for those values in here. Now, I'm going to get rid of those two things, and I'm going to start to solve, but I'm going to rewrite it. I want to make my life easier, right? But I'm not going to do that yet. I'm going to make my life easier over here. I'm going to go ahead and distribute, and I'm going to multiply. I'm going to use those little distribution lines so you get used to seeing. I'm going to multiply this by negative 4, and I'm going to multiply this whole value by negative 4. So negative 4 times 3x is negative 12x. And then I'm going to multiply negative 4 times negative 1, and I end up getting a positive 1. So remember, this negative hangs with this 1. So negative 4 times negative 1 is positive 4, and that's going to equal negative 20. Now that I'm there, I'm also going to solve for the positive 20 because I have to. All right, so negative 12x plus 4 equals positive 20. I guess I'll have to get rid of that when I move on. But I have to solve these two things together because all of my absolute value equations are going to give me two separate answers. And here we go. First step, of course, is to subtract 4 from both sides. And that goes away. And so now I have negative 12x equals negative 24. Right? Negative 20 and negative 4 is negative 24. And now I'm just going to divide both sides by, obviously, I'm going to divide both sides by negative 12. Divided by negative 12. And what I come up with is x equals 2. And if I look back here and I just plug the 2 in here, 2 times 3 is 6, minus 1 is 5. 5 times negative 4 gives me negative 20. So I do know that this is a correct answer. It's a valid answer. It works. Let's go ahead and solve for the opposite of that, which is positive 20. Let's start doing that math. And I got to get back to this color. And I'm going to do the same thing, minus 4 from both sides, or subtract 4 from both sides. That goes away. 20 minus 4 is 16. But wait, now I have something that looks kind of gross. Negative 12 times our variable equals 16. This is going to mess us up, right? Well, I'm going to go ahead and do this division. Divide both sides by negative 12. And the truth of the matter is, x is now going to equal negative 4 thirds. And if I plug this in, believe it or not, I'm going to do the math down here. 3 times 4 negative 4 thirds minus 1, take that absolute value, and then multiply that by 4. So 3 times negative 4 is negative 12. Negative 12 over 3, because when you multiply straight across. Minus 1, give it absolute value. Well, this ends up looking like, oh, well, negative 4 times, this negative 12 over 3 is obviously negative 4. Minus 1 gives me negative 5. So I'll just show that. Negative 4 times the absolute value of negative 5. Well, the absolute value of negative 5 is 5. So we actually do have negative 4 times 5, which is also negative 20. And I know that was a long way to go for this kind of answer, but I wanted you to know that you could check your work and know that that fraction that you found is actually a valid answer. So I'm going to get rid of that. I'm going to go back, and if I can, I'm going to move this over. Let's see if I can drag and drop this sucker. Yeah. If I can get it up there, there we go. And then I'm just going to move it over and see if I can fit it in this space. That's good. And then I'm going to show you there's also an easier way to do this. I apologize for the sound back there, but I can't help it at the moment. There we go. I hope this is going to work. If I, let's get over here, if I divide both sides by this negative 4 out here, I'm going to have easier numbers to deal with. All right? And so when I do this, I'm going to cancel out my 4s. And then negative 20 divided by negative 4 is just 5. Well, didn't we say earlier that all we had to do was find a 5 or a negative 5 in here? Well, I'll be darned if 3x minus 1, and we take the absolute value of that, we need to find a 5, right? So, what values? 5 and negative 5. So let's go ahead and solve this for both 5 and negative 5. So 3x minus 1 equals 5, and 3x minus 1 equals negative 5. Right? Okay, so let's go ahead and do the math. We're going to add 1 to both sides. And that's super simple, right? This goes away, this becomes 6, and 3x equals 6. Well, oh, look at that. Divide by 3. I'm going to use this color. We haven't used this color yet. Divide by 3, divide by 3. And x is equal to 2. Just like that one, it works out just right. Oh, thank goodness. Okay, well, go back to this color, start doing it again. We add 1 to both sides. Okay, well, this goes away, right? And this becomes negative 4. And if you're looking, looky, 3x equals negative 4, it looks an awful lot like this guy over here. And there it is. Let's divide both sides by 3, divide by 3, and x is equal to negative 4 thirds. Just like we found before. And so we know that it works if we plug it in. I'm not going to go through all of that nonsense. Now, for our purposes tonight, I'm going to leave this type of work at this. I'm going to skip to number 4 so that I can show you how to graph an inequality, which means I'm just going to go up here and drag this whole thing and make it disappear and move on to the next piece because this video is getting to be a little bit long. All right. The last thing I want to do is solve this and put it on a number line. So 7 minus 3x is less than or equal to 2x plus 6, right? So far, so good. Not a big deal. There are a couple of ways you can do this. I like to take my negative x's and make them positive and move them that way. I like to have all positive x's on one side. Some of you like to have your x's on the left and your constants on the right. I'm going to show you my way because it doesn't hurt. So I'm going to show the opposite of minus 3x over here. And if I do that here, I need to add 3x over here. So these two things are opposites, so they go away. And this is 5x, 2x plus 3x is 5x, plus 6. Here's our little less than or equal to symbol. And I'm going to show you how to read this later on after I've done the math with these. Let's go ahead and subtract 6 from both sides. Right? And then this goes away just like before. And 7 minus 6 is 1. Is equal to 5x. Now we have 5x is greater than or equal to 1, or you would say 1 is less than or equal to 5x. You could say it either way. Either way, it's exactly the same, but I want you to start with, when you read it, to read it x first and in that direction. The last thing we need to do in this equation is go ahead and divide. So I'm going to divide by 5. But, sir, I'm afraid of fractions, and this becomes x is greater than or equal to 1/5. Is this difficult to put on a number line? Nah. You just have your number line there. And the one we had on our sheet was pretty cool. This was about 1/5 here. And we'd say that the x's are greater. Why is it greater than or equal to? Because the fishy mouth is open to the x, etc., etc., or 1/5 is less than or equal to. So we're talking about everything greater than or equal to, 1/5. So I'm going to use a closed circle, right? And then I'm going to graph greater than, right? And that's it. That's all we needed to do. Tomorrow, we're going to talk about compound inequalities. I thank you for your time, and I hope this helps a little bit.